Hello, Mr. LaBeouf again. In this video, we're going to consider the quadratic function f of x or y equals 2x squared minus 5x plus 3. We're going to find the zeros of this function. We're going to try find the two values of x that will make the function equal to 0. And graphically, of course, that's where the graph of the function crosses the x-axis. The x-axis is where y, or the function, is equal to 0. We're going to find the zeros of the function by factoring, and then by completing the square, and finally by the quadratic formula. We first notice, however, that the graph of the function crosses the y-axis at 3, because when x is 0, clearly the y will be 3. So I've put that on the t-table. This is the y-intercept. Now, as far as factoring this trinomial is concerned, this is a moderately difficult one. Not particularly hard, but you have to have a little patience whenever you're factoring. We notice that we need a 2x and an x in the first position. We notice that the c, in this case the 3, is positive. So to get two numbers that multiply to a positive, they have to either both be positive or both be negative. But the middle term is negative. So we have to have an addition of two numbers to get to a negative. That can't be by two positives. So the two numbers we need here are both negative. And of course, because this is a 2x, the position makes a difference. And the way this one will work out is to put a -1 there and a -3 there. And of course, whenever you have to factor, you can verify what you've done by multiplying. 2x minus 3 times x minus 1. 2x squared minus 2x minus 3x, that's -5x when you combine them, and plus 3. So now we have to set each of these factors equal to 0 and solve for x. Well, this one's obviously 1. If x is 1, this parentheses is 0, and it doesn't matter what that is. You'll get a true statement when x is 1. The left side will be equal to 0. And the other one can be done mentally as well. That's pretty obviously the x has to be 3/2. If we want to show all the work, we'll set each factor equal to 0 and solve for x. So when 2x minus 3 equals 0, the 2x equals 3, and the x equals 3/2. So I've put those two values into the t-table. When x is 1, the function will be 0. When x is 3/2, the function, or y, will be 0. Those are the two x-intercepts of the graph. We're now going to find the same two zeros of the function by completing the square. I've copied the t-table over here. And in this case, there are going to be two preliminary steps to completing the square. The first will be to subtract 3 from each side to get 2x squared minus 5x equals -3. And in the process of completing the square, we have to make sure that whatever we have is equivalent to what we started with, equivalent to this original equation. So doing the same thing to both sides. And the second preliminary step here is when you're completing the square, you don't want you don't want the coefficient of the x squared to be anything other than 1. So what we need to do now is divide through on both sides by 2. The right side, of course, will be -3/2, dividing the -3 by 2. And to divide on the left side by 2, of course, 2x squared divided by 2 is x squared, which is what we want. And -5x divided by 2 will simply represent that as -5 over 2x. So now we have x squared minus 5/2 x equals -3/2. We've done the two preliminary steps, and now we're ready to complete the square. And notice I left a little space here for the number I'm now going to add to both sides, so that on the left side I have a perfect square trinomial. Now here's the key to completing the square, as we saw earlier with an easier case. the coefficient on the x term is -5/2. We need to take that number, divide it by 2, take half of it, and then square that result. Well, half of -5/2 is -5/4. That's a little bit of fraction, multiplication or fraction division that at this point should be pretty apparent. Half of -5/2 is -5/4. Square the -5/4. -5/4 times -5/4 is 25/16. Positive, of course. And notice I've added that 25/16 to both sides. You have to keep the equation equivalent. On the left side, we now have a perfect square trinomial. We created it, so we should be able to factor it. And the number that's going to go along with the x, see, we need to know what goes along with the x there in the parentheses. Well, it's going to be the same -5/4 that we got when we took half of the -5/2. It's just going to be the -5/4. And you should confirm that for yourself by multiplying x minus 5/4 times x minus 5/4 and make sure that you get what's above it. Now on the right side, I'm going to get a common denominator of 16 here. I'm going to think of the -3/2 as -24/16. Multiplying the top and bottom by 8, I get -24/16. Plus the 25/16 is 1/16. These two fractions add to, or these two rational numbers add to 1/16. So now we have a number squared equals a number. Now, this number here, 1/16, is positive. That means that there will be two real roots. We already know what they are. If you're completing the square and you get a negative number over here, then there are not any real roots to the function, and that's something we'll deal with in the future. We have a number squared equals 1/16, so that number equals plus or minus the square root of 1/16. So the x minus 5/4 equals plus or minus the square root of 1/16. Now, 1/16, the square root of 1/16 is rational. The square root of 1/16 is, of course, 1/4, because 1/4 times 1/4 is 1/16. So on the right side, we have plus or minus 1/4. And what we're going to do now to solve for x, our final step is to add 5/4 to each side. Adding 5/4 to the left side will isolate the x, and we'll add the 5/4 to that right side, putting it there in front of the plus or minus 1/4. And now, following the two paths, the plus path and the minus path, we have 5 plus 1 over 4, or 5/4 plus 1/4, 6/4 or 3/2. And following the minus path, we have 5/4 minus 1/4, which is 4/4 or 1. So there they are. There are the same two roots, or the same two values of x that will make the function equal to 0 that we got earlier by factoring. Finally, the quadratic formula. And with this particular function, a is 2, b is -5, and c is 3. So, of course, if 2x squared minus 5x plus 3 equals 0, then x will be, and we'll just plug into the quadratic formula, x will be the opposite of b, negative b, or the opposite of b, which is 5, plus or minus the square root of b squared, b is -5, b squared minus 4 times a, which is 2, times c, which is 3, all over 2a. A is 2 this time, so it's all over 2 times 2. Or x equals 5 plus or minus the square root of all over 4. The 2 times 2 is 4. Now inside that square root sign, we have negative 5 times negative 5, which is 25, minus 4 times 2 times 3, which is 24. 25 minus 24, or simply 1. And once again, we have the underneath the square root, the b squared minus 4ac, is a perfect square. 1 is a perfect square, which goes along with the fact that the two roots that we have are rational. So finishing up here, we have x equals 5 plus or minus 1 over 4. The square root of 1 is 1, of course. And we follow the two paths as before with completing the square. 5 plus 1 over 4 is 6 over 4, or 3/2. And 5 minus 1 over 4, 4 over 4 is 1. We get the same two roots that we earlier got by factoring and also by completing the square. So that's it for this particular function. I hope you've enjoyed exploring the roots of this function. There are many other things that we could do, of course. We didn't bother with the vertex, and we didn't bother to graph. But if you think back to a previous video where we talked about how to find the vertex, you might want to try that for yourself. And of course, using Desmos.com or some graphing calculator application, take a look at the graph. Make sure it conforms to what we found algebraically. That's all for now. Bye-bye.